Hello everyone, I'm Tang, and my supervisor is Mahmoodi, and I'm from University of Southampton. Today I'd like to talk about reach detection and analysis of susceptibility-weighted magnetic resonance imaging in neonatal hypoxic-Ischaemic encephalopathy. And next, I will use SWI instead of susceptibility-weighted imaging and use HIE instead of hypoxic-ischemic encephalopathy. And here is a flowchart of our whole method. You can say we use active contour models and feature extraction. And we also use ridge detection and Hoof transform and ridge segmentation. Then we got 4 features to do the classification and the regression. And here, this slide is to introduce the feature selection. And first, we input the original HISW image, and then we use active contour model to remove the background. Actually, we mainly remove the skull of the brain, you can see, and then we use ridge detection to detect the ridge of each vessels, and then we use the Hoof transform to remove the center line of the brain, and then we do the ridge segmentation to segment the every ridges in the brain, and finally we get 4 features: vessel width, vessel intensity, and vessel length, and vessel eigenvalue. And then we use a histogram of this parameter as the feature vector to do the classification and regression. And here, this slide is to introduce how to measure the vessel width, intensity, and length. And here is a part of HISW image, and you can see here is a part of vessel blood, and the black is vessel blood, and then we use ridge detection and canny to get the canny edge and ridge. You can see the red line is the ridge and the white line is the canny edge. And then we use the ridge and canny edge to compute the vessel width, and we use the point on the ridge to measure the shortest distance between the canny edges as the vessel width, and then we use the pixel value to calculate the vessel intensity. You can see the white pixel is from canny edge, and the red pixel is from the ridge. So we use the difference between the ridge, the pixel on the ridge, and the pixel on the canny edge to get the vessel intensity, and then we calculate the pixel on the ridge one by one to get the vessel length, because before we measure this, and we have segmented the each vessels. Okay, here is the result of our classification. And these 6 images is our intra and interclass variation image, and of different features. You can see this is the inter and interclass variation of width feature, and this is for intensity feature, and this is for length feature, and this is for Hessian eigenvalue feature. And these two is combined these features. And these 6 images is to show the performance of the same group and the different group labels. And here, this is the CMC curve, and this is a ROG curve. And you can see the best performance is combined width, intensity, length, and Hessian in both CMC curve and ROG curve. And here is the best result is from combined width, intensity, length, and Hessian eigenvalue feature vectors is 78.67%. And here, this slide is to introduce the result for regression, and we use SVM regression to do the regression, and by using the two scores which are cognitive scores and motor scores. And we can see the mean relative error. We use the motor scores to do the regression to get the better result, and to get the better regression. Actually, the database is small, so in the future work we will to add more data to improve our regression. Today, we extracted some features from SW imaging of infants for the HI outcome prognosis. And first, we remove the background of the outside of brain, and then we detect the ridge of vessels, and then segment each ridge, and then calculate the vessel width, intensity, length, and Hessian eigenvalue, and use the histogram of these parameters as a feature vector to do the classification and the regression. And in our future works, the main work is the most important work is to determine what location of the brain has been damaged to predict the behavior of a newborn, and because now we can know the different neurology outcome of the HIE infant, but we still don't know where is to cause the HIE in the brain of the infant. So this is our future work. Thank you. Thank you, everyone. if you have any question, you can ask it to me. Maybe you can send the notes, I think, because this is an online conference. Thank you. Thank you, everyone.